Arjumand Yaqoob is at Qualcomm Incorporated. He holds a bachelor's and master's degree in electronic engineering, gained experience by working in companies like Qualcomm and Intel. Currently, he's in San Diego, California. He has about 15 years of experience working in design verification. And the presentation of his title is SIP, standing for System and Platform Verification Challenges. And just to give some background to this, this is taken from a white paper that a number of us has been working on, Arjumand included, for the Open Compute Project, OCP. And it will be forming the white paper that will be released later this year. And over to you, please, Arjumand. Thank you.
Thanks, Mike, for the introduction. So, as Mike has basically told, that this paper is this presentation is based on that white paper, and which is basically being in the development and should be released later in the year. So, main aspect of this presentation, which is from the that white paper, is that we are going to describe about the verification challenges that a SIP, which is built from multiple chiplets, has, and that can come through a SIP verification, and what are the recommendations and how we can overcome these challenges, because these comes in a wide variety of all the aspects and subjects, and we are going to cover this in this presentation. So basically as an outline, I will go over. I will basically define introduction and overview of these kind of systems which are based on chiplet, and then I will go over the challenges that we have identified and have described in the white paper as well, for all of these SIP verification related challenges, and then I will go over all of the related challenges that we have described in the paper, and then with proposed solutions and recommendations that we have actually been describing in the paper, and then I will close out with what are the next steps and the future work for us, and then I would be open for any question, of course. So basically, as Frank has also been talking in his presentation, as all of you know, the chiplet is basically a functional integrated block, and a SIP, which is made from multiple chiplets, is basically is a new concept that's coming in the chip design. So normally the SIP, the basic classification that we can do is like the SIP can be heterogeneous or homogeneous. So that is basically meant that they can be of the same type with the same manufacturer and the same process node. And then likewise, they can be of different types. For example, a compute, a network, and a memory chiplets connected together. And that poses many different challenges when we will talk about the verification challenges later in these slides. So normally how we are going to verify is basically the same techniques that we use in the conventional SOC verifications, simulation, emulation, formal, etc. These are the basis of when are we going to verify any SIP. These are definitely a basis for the verification of the SIP-based systems. But with these SIP, basically the verification challenges are basically different as compared to SOC verifications, and that is what we are going to describe here. But our main fundamentals will remain same. For example, when we are verifying as an SOC, we definitely are going with the assumptions of like the IP level pre-verified IPs, and we are building over that for the SOC verification, and that will be the same thing with the SIP, where we will start with the chiplet, which are pre-verified, and with the verification environment that we have received, and we are going to integrate them into the SIP, and we are going to verify our SIP. So overall, the scope of this presentation will be based on, as described earlier, on that white paper, which is being in the development and which discusses all the challenges and recommendations. So normally, what are the main challenges of the SIP is basically that are like not much different if we go from the aspects of SOCs, but they have their unique characteristics when we are talking about the SIP. It's basically when we are going to simulate a SIP with many different vendors providing the chiplets, which have been integrating in by many different manufacturer with on different dies and different process nodes and different types. That will propose a big challenge as well. And then definitely the type of the SIP, which is heterogeneous or homogeneous, will pose different challenges that will be discussed. And then the scalability, which will be coming when these SIP will be becoming huge, as we have seen, like with the scaling of SOCs and the scaling of chiplets based system, which is SIPs, will basically increase, and then we'll have more challenges around it, and then different other challenges like with the basic clock verification, reset verification, and then the main is the coherency issues when we'll talk about the heterogeneous SIPs and the security aspects as well, along with the with how we are going to deliver and basically make recommendations on the deliverables of IPs and VIPs involved, and then the general criteria about how we are going to sign off for a SIP verification, because that's very important to basically formulate recommendations on it, and then basically define how we can say that it's a good verified SIP. So if we go over one of the first challenge that basically has been described it is based on the system simulation. Basically, that is the artifact of the thing that its SIP is basically based off of multiple chiplets, and these are coming from many different vendors, and these basically have done their own development using their own coding styles and their own design flows, and using their simulation and tooling technologies and conventions at their level, and then they have some licensing requirements as well for their IPs. But what we are going to face here is basically when we are going to verify this as a system, we will have to face all these challenges that will come together in a SIP verification environment. So we are going to basically provide some recommendations in that scenario that basically will help in the sense that if we can get kind of everything compiled into standalone libraries from the providers, and if we follow the providers are going to follow about the basic fundamentals of their designs, that they all should be like X-propagate tolerant, and they should be all have a zero delay kind of stuff incremented, and everything from the encryption is well set up, and then they have all the design rules and lint rules follows, that will make the life easier when we are going to verify a SIP. So that's basically kind of recommendations that you go are described in detail in the paper. The other is basically the next one is a scalability, which is also very big, but that is like coming from the conventional SOC. So for example, like the SOCs are going bigger and bigger, and the SIP are also will be becoming bigger and bigger. So the main thing is that our simulators are like single-threaded, and they basically always work in a single-threaded scenario. But what we are going to, what we have discussed and going to propose here is about a multi-threaded facility that with the introduction of a pipe to API mechanism, what we can do is basically we can split the design into different over multiple processor for simulations. That will actually help in creating the fast simulations, and basically on the scalability side, it will help to go faster, and that's basically is going to be the way when we have these big challenges, because this is going to be huge with the SIP. Definitely, the next thing is more important in the sense when we are going to define a verification environment, we need to be very particular, because when these chiplets have verification environments at the chiplet level, and then they have used a basically methodology like UVM, they need to be compliant on it, because if there is some non-UVM related code, then that has to be defined clearly, and the recommendations should be clear over there, because when we are going to verify ASIP, all these environment which they have done at their level, they are going to be combined. So we need to apply approach like how we can reuse these verification environments that will come based on the recommendations and the standards followed by the chiplets providers, basically. And of course, we need to define that how to be compliant at the SIP level. So the approach, how we do a kind of a layered approach, where we need to define a small and focused tests and sequences, and define a layered approach to basically go over the providers, and then that will help in a seamless SIP verification. And when we go over the basically the criteria of how we will be talking about the coverage closure, that is also very important. But that goes related to the how we verify an SOC, because then when we are going to
Arjumand, you have 2 minutes left.
Yeah.
You should start wrapping up now, please.
Yeah, sure. So when we have when basically we are closing the coverage, we need to define the definitely the aspects about, like, we at the SIP level, we are concentrating on the integration and verifying the different configurations, which basically are not covered the IP at the chiplet level. So we need to be very clear about the outline and what we are going to do. So that is basically described in this slide about the criteria and how we are going to do it. So, and then the next step comes into the system integration, basically, where that is the main concern, because when the different chiplets are sitting in a SIP, the coherency is a big issue, and then there are like the interrupt and the data bandwidth and latency and error rates and stability, and then some dynamic scenarios, how they are changing. So all these challenges are basically will be coming in a SIP, and then how to overcome this basically will be using with the standard protocol like Compute Express, and then the optimizations across these interrupt basically functionality, and then how this will be done with basically with the introduction of the standard interconnect technologies, and how to basically cover the error rate and all.
Okay.
These
You've run out of time. Okay.
Yeah.
Okay.
Okay.
Thanks, Arjumand.
Thank you.
Okay.
Yeah. We have some other like
okay, we've run out of time, unfortunately.
Yeah.
Unfortunately, we've run out of time. So we'll go to the next speaker now. Okay. Thank you very much, Arjumand. Thank you.